distribution of your marks. So basically this is for 100 marks theory. All right, theory is for 100 marks, and then theory 50 is for your midterm. This is your end term. In end term, we will be divided. The marks will be like this: 50 will be your, 40 will be your MCQ. All right, and 10 marks will be viva or assignment. All right, assignment. But mostly we will be going for the viva. Regarding 30 marks for the midterm, 20 will be MCQ, then again same 10 for viva or assignment. Viva means we will be calling you through, we'll have a viva through WhatsApp or through video call or something like that. Okay, viva. And then 10 marks, 20 marks will be based on internal plus your assignment. All right, this will be it. This is how we are going to distribute the marks. I think everyone is clear with that. All right. So 20 marks internals. We will be having 2 internals. Most probably we will have 2 internals. So one before the midterm and one after the midterm. And there will be assignment will be given every week. I will be giving you assignment. All right. So you have to submit your assignment. What you have to do is that you have to take a when you submit. So every week I'm going to give you assignment. So say suppose if we have a class on this one, and on Friday I will give you the assignment. Then you have to submit on Monday. Okay, I'll give you 2 days time, and then you have to submit on Monday. When this one, when you submit, you have to write it down in the papers. Your answers should be written down in the papers neatly. Then you have to take a screenshot and you have to send it to my WhatsApp number, personal in the personal messages, along with your name and enrollment numbers. Okay, and the due date and time will be allotment will be given in the question also, in the assignment questions. All right, and then viva, they have the for viva. I'll asking you some questions related to your subjects that they are going to be studied in this particular semester. It can be your theoretical, or it can be based on your lab programs. So it will be a mix of both theoretical as well as your lab. So 10 is in your hand. Whether you give your answers or not, it depends upon you. Right, 20 is and one more thing is, in submission of assignment, you cannot do copy and paste directly from one another. Okay, so and one more thing, don't copy directly. If you find the questions in your internet or something, don't directly copy. Just just make it a little alteration in your answers, and then you submit it. Right, and the submission of your assignment has a lot of weightage when you submit. When you say, like, if you submit like after the due dates, that will not be taken into consideration. Okay, you give a lot of excuses, ma'am, I have this, I have that, there is no internet connections and all, then that will not be taken into consideration. So you have to remember all these things. Once I given a due date, you have to submit your assignment within that time limit. All right, within that due date. All right, and regarding this one, classes. The classes are very important. Since most of the students who are residing in a remote areas, they are unable to access the internet because of the network internet connectivity and all. They have going to face lots of problems. I know that, and as well as that your data might be finished. There's a limit, right? For every per day there is one certain limit, for 1 GB or 2 GB. So I have to see all this your problem also. If you have a problem regarding this, then you can inform me in advance. Ma'am, I have these problems, so I cannot be able to attend the classes. So can you make this one arrangement where I can see the lecture videos those lecture videos or those topics that I miss out, then what we are going to do is that I'm going to make a uh, this one lecture videos of that particular topics, and I'm going to upload in your Google Classroom, so that whenever you have a data, whenever your connectivities are, network is strong, then you can access it, you can download it, and you can see that. All right. So if you have a problem regarding your network connectivity, you just inform me. So at the time of examination, at the time of Viva examinations, or when you have and a midterm examinations, what we heard most of the complaint from the student is that they have a problem with the network, they have a problem with the mobile, they have the problem with the laptops and all. Right. So what you have to do, you have to inform us beforehand, before the exam commencement of the exams. All right, so that we can postpone the exams, by some hours or some minutes. All right. So if you have any problem regarding the subjects, you can drop down your queries in the Google Classrooms, where you find it difficult to understand the particular topics. So what you have to do, don't send me particular messages, this and that and that. What you have to do is that whatever your query is, whatever query related to the subject, related to the particular topics, you just drop down the query in the Google Classroom. That query will be, we will discuss and we will rectify your queries. All right. So we will start. I hope everyone are clear with the how the marks is going to be distributed. So we will start with the class. So the very first topic we are going to start is computer. So computer architecture and organization. So what basically is this computer architecture? You have heard of this word architecture, right? I hope everyone have heard of this word architectures, and then what is organizations. So, but before that, let's understand what basically is a computer. I hope everyone have seen a computers, right? Everyone have seen what is it basically a computer is, right? So what basically is a computer? We know that it is an electronic device, right? Electronic device to do a particular task to do, with to solve a particular problems, right? You can call as an electronic, a very first electronic calculating machine, or you can say that accepts the data, or that data must be in a digitized input information process. All right. So you know what is the computers. Now we have different type of and what is the program. So what is the programs? It is basically a list of instructions to do a particular task, right? A list of instructions are called as programs. And internal storage. So internal storage of a computer is called a computer memory. We all know this, right? So computer means a device. What type of device? To solve a particular task. Now we are good. Let's understand the different type of different types of computer. So you have seen computers, but what are the different types of computers? First one is your personal computers. I have seen these personal computers in the lab also, right? What is this personal computers? This is one of the most common type computers that you find in your schools, in your homes, business offices, etc. All right, it is the most common type of desktop computers with processing and storage unit, along with the various input and output devices. You know this, right? And then we have a enterprise. We have enterprise computers, right? Actually, this type of computers are basically used for business data processing in medium to large corporations that require much more computing power and storage capacity. All right, and then uh, next we have workstation computers, or you can say workstations. What are those computers? This type of computers are basically have high resolution input output units, input output graphics, okay, graphics, graphics capability, but with the same dimension, as that of your personal computer, as your personal computers, and they are basically used in engineering applications of interactive design works. All right, so these are the general, and we have supercomputers also. Supercomputers, that's supercomputers, computers. All right, so they are basically used for large scale numerical calculations required in applications like you have a weather forecasting, weather forecasting, and this one, they use this supercomputer, and we have mainframe also, notebook computers, so these are the different type of computers that you know that. All right, next is, what are the functional units of a computers? Functional units of a computer are the functional units of a computers. So when we talk about computers, this computer basically consists of five functional units. Okay, five functional, functionally dependent, functionally dependent, or you can say independent main parts. What are those independent five function independent main parts? What are they? These are your unit, input unit. They have a output unit. All right, we have a memory. All right, memory units, and then we have arithmetic logic unit, output unit, the output unit, right? This arithmetic and they will become inside this arithmetic, and then control unit also can come inside. We have control unit, control unit. Now you see here we have five units here. We all know what are this. What are these input units? What are output unit? What is the role of memory, arithmetic logic units, and control units? So now you see here in your first semester you have studied about different type of you have studied about input unit, output unit, right? What is input unit? These are the input devices to accept the data from the users, right? And the output unit is, they are the to give your results. You have the memory storage unit. Storage is basically used act as a storage device. An arithmetic logic unit, they are used to perform your arithmetic and logical operation, your in and or gates. And what is this control unit? They are basically control and coordinates. Control and coordinates what type of instructions that has to be performed. All right, suppose if I give you an instructions, suppose if you have a task to do, okay, suppose if you have to task this addition and subtractions, so this control unit will decide what is the instruction. Okay, that is, the instruction is addition of two numbers, so it will decide and it will direct. Okay, it will give an this one uh, control and coordinates what are the instructions to be performed by the arithmetic logic unit. Okay, so this is so you already studied in brief in your first semester regarding input output unit, right? So but in here in computer organizations and architectures, we are going to learn the functional units of computer in details. We know what is input unit, we know what is output unit, we know what is memory. Memory is just for storage, right? We learn like that. But here in this computer organization architectures, we are going to learn in brief, in details about the memory unit, what is arithmetic logic unit, what is control unit, what are input unit. All right, so the deep details of of all this unit we are going to learned. All right. So next is computer architecture and computer. So let's start with the one computer architecture, architecture and computer organizations and architecture. Organization and architecture. So what is computer? So we know what is computer and what is organizations and what is architecture. So what this computer organization is? This computer organization is basically, it refers to the operational units and their interconnections, interconnection. All right, interconnections that realize the architectural specification. Realize the architectural specifications. Okay, so in your Viva, you can ask how will you define a computer organizations. Then you have to say these are the, it refers to the operational units and the interconnections that realize the architecture specification. Or in some of the books, it has been called as, this computer organization. It has also called as it encompasses the specification of an instruction set and hardware units that implement the instruction. Right, that implement the instruction. All right. Next is computer architecture. What do you mean by computer architecture? So what is architecture? This computer architecture, it refers, they have a definition given like this. The architecture design of a computer system is concerned with specification, various function module, so that processing, structuring them rather to form a computer system is called as a computer architecture. This is your, given what do you call given definition you will find in different type of books. Okay, so what is actually computer architecture means? It refers to the attributes. Okay, it refers to the attributes of a system. Okay, that is, what are the attributes? What kind of attributes? That will be visible to the programmer. Okay, so these are the attributes that will be visible to the programmers. Or you can say in that a computer architecture refers to the attributes that have a direct impact on the logical execution of the programs. Right. So this is the definition of a computer architectures. So here I have mentioned the word called attributes. So what is the attributes? Attributes are nothing but it includes number one, instruction set. So please bear with my spelling, all right. Instruction set, and we have a data types, the number of bits used to represent your data types. Then we have IO mechanisms, output mechanisms, and techniques. Okay, and techniques for addressing modes, addressing memory. So these are the attributes. Okay, these are the attributes of the computer architectures. So on the other hand, this the organizational attributes. Okay, this organization. So here, what are the attributes included in computer organizations? It includes details. Okay, includes the hardware details, transparent to the transparent to the peripherals, right? To the peripherals. All right. So there's a definitions, okay, about the computer architecture and computer organizations. See, the main difference between these two is computer organization means how to do. The question is the difference between computer organization is how to do. Okay? How to do. And computer architecture means what to do. Right. These are the main definitions difference between these two terms. So you can go through, or you can go through different books of computer organizations, architectures. I think you have a syllabus in your college website. No, you can refer William Stelling. William Stelling is the book. Okay, so William Stelling. I think it's Stalin Stelling. All right. So you can refer these books. In that, you will find the definition of computer organization and computer architecture. So you can refer any of this book by William Stevens. They have different editions and all editions of this particular books. Now, let me start with the very topic. First one is arithmetic. This is the very first chapter. Okay, arithmetic logic unit. Arithmetic logic unit. What is arithmetic logic unit? Anyone can tell me? Can on your computers or on your microphone, and you just tell me what is arithmetic logic unit? Can anybody can explain me?
Actually, it processes all the work. Actually, it is in the CPU. It processes all the work which we do on a computer.
Okay, that means I hope everyone have seen the computers, right? You have seen the computers? You have come to the lab. You have seen the computers. You have seen your this one, your monitors, right? The monitor is your output devices. Your keyboard was your input devices, and then you have the processor, right? The processor. That is inside this we have arithmetic logic units. What is then we have a control unit, memory units, and we have right. So what is arithmetic logic unit? Once a friend has told it is your what was that definition? Can you repeat me? Can you repeat me again?
It processes all the work in our computer.
Okay, process your works. So most of your computers operated are executed on. All right, most of the computers operate the operations are operated in arithmetic logic unit of the processor. All right, of the processor. We know that arithmetic means your addition, right? We have addition and subtractions, then we have multiplications, and then we have divisions also. All right, etc. So the operands, okay. See, you have to learn this string operands. We will not talk about this operands and all. You will not understand now. So these are the operators. All right, these are the mathematical operations that are going to be performed inside this arithmetic logic unit. All right, so the operands are brought into the arithmetic logic unit from memory and stored in a high-speed storage elements called as your register. That we will talk about register, what is memory, and we will in the later part of the syllabus. And according to the instructions given, the operation is performed in the required sequence. All right, so this arithmetic logic units. So what we are going to learn in this arithmetic logic unit, we will discuss about. Okay, just a second. All right, I have to see the syllabus. Okay, I have to see the syllabus. All right. Okay, let's start. As we know that a processor, when we talk about this, a processor consists of a data processing and control unit. We all know this. These data processing units perform all your arithmetic and logical operation. All right. So in this chapter, what we are going to do is that we are going to study the data types of operands used for arithmetic operation in computer and computer arithmetics. I hope you have already studied the topic called as the number system. I hope everyone has studied, right? So based on this number system, so number system means your binary, decimal, hexa, and octal, right? So based on this number system, two basic data types are implemented in the computer system. The first one is called as your fixed point numbers, fixed numbers, and number two is your floating point numbers. Okay, representing numbers in such data type, that is either in fixed point numbers or floating point numbers, is commonly known as fixed point representation and floating point representation. Right, representation. So in a binary number system, a number can be represented as integers or as fractions, depending on the design. The hardware can interpret numbers as an integer or fraction. All right. So let's learn. First one is let's start. This one. These are all theoretical. Okay. And one more thing I have to forget to mention about this particular subject. This subject is basically we have mathematical part also as well as your theoretical part also. So students find very boring this subject. I have seen many students they feel like sleeping when they heard this subjects, because these are all theoretical, theory and all. No? But you have to learn. You have to study this subject very clearly, because this subject will be very important in your when you give exam for GATE and all. No, this subject is very important. All right. So please bear with me. So first data type that you are going to learn is fixed point numbers. So what basically is a fixed point numbers? So this fixed point numbers, all right, these fixed point numbers are referred to as you can say that this fixed point numbers, or you can call as your integer numbers, or you can call as the integer numbers. Integer numbers are represented in two forms. One is called as a signed integer and unsigned integer. What is signed integers? Signed integers signed integers are those, just a second. So sign means, so unsigned means, unsigned integers means what is this unsigned integers represent? It represent only positive numbers. All right, so positive numbers, positive numbers. And to represent negative numbers, all right, how to represent negative numbers? So in order to represent negative numbers, various techniques are used, because computers does not have the provision to represent negative numbers, or you can say as computers does not know what is negative numbers, right? So in order to represent your negative numbers, we are going to study various techniques. All right, various techniques to represent your sign, that is negative numbers as well as positive numbers. So how we are going to represent What are the different techniques to represent your signed integer numbers? The first technique is called as your sign magnitude to representation. Number 2 is ones complement. Then the second is seconds complement. All right. So these are the three techniques to represent your negative numbers. All right. So positive numbers, if it is the unsigned integers, computers can directly understand that is a positive numbers. What about if I have to represent -9? Computer does not know -9, right? Does not have the provision to represent -9. You cannot simply put -9. So what we have to do is that we are going to, this one. In order to represent negative numbers, we will use various techniques. What are the techniques? That is the sign magnitude representations, first complement and second complement. All right. So let's understand the first one. That is your first sign magnitude representation. All right. So what is sign magnitude representation? We will discuss just a second. All right. I hope everyone can hear me also, right? So in sign, the first one is your sign. What is basically this sign magnitude representation? So in sign numbers, it is necessary to represent negative as well as your positive numbers. So when we say sign number, it means both positive as well as negative. And what about unsigned? Unsigned means only positive. Unsigned means only positive. Only positive. All right. So in sign numbers, it is necessary to represent both negative as well as positive. So I'm going to represent a sign magnitude format. How we're going to represent? There is a format. Okay. So we will take this and draw a table. 8. I hope anyone can see now. So this first one is called as your sign. First one is called as S. I'll just bring down here. This is called as your S0. Okay, it has to written here, but I'm writing it here also. Then this one is S1, and this is S7. Okay, right now this is a figure of a sign magnitude format of 8-bit sign numbers. 8-bit sign numbers. So in sign magnitude representation, the most significant bit, that is your leftmost bit, is used to represent your sign of the numbers. Which one is your leftmost? This is your leftmost, right? This is your leftmost. What is this? This is the most significant bit, and this is your least significant bit. So this is the leftmost and this is the rightmost. What is this most significant bit is used to? It is basically used to represent your sign, whether it's a positive or a negative. All right. So if the most significant bit is 0, suppose if the most significant is, suppose if it is 0, then what we have to say that the particular number is a positive numbers. All right. And if the most significant bit is 1, then the number is negative. Suppose if I write like this, if we have a write like this, 0, 0, 0, 0. Suppose if we have a write like this, a number decimal number as 4, right? So if I have to represent these numbers using 5-bit, or you can say 4-bit, or the 3-bit or 4-bit. So let's say you want to represent this 4, decimal 4 in 4-bit format. So what will you write? So 0, or you can say 3, let's say 3 bits, okay, because it is 3, this one. Change into 2 binary numbers. Now you see do you see any sign here? No sign, right? But it will be taken as a positive numbers. So when you represent this, so I'll take this. So how will you represent? I'll take 3, 4. Just a second. It's a 4-bit numbers, right? 4-bit numbers. So how will you present 4, 4, 1, next is 0, next is 0. All right. Now this is your most significant bit. Now you see that there is no sign, no negative sign here. So it basically the positive numbers. So we will write as 0. All right. So we will write as 0. Suppose it is -4. All right. For the just time being, -4 means we will represent as 1. I hope you all understand this. That means if your most significant bit, if you find this one, this is the most significant. If you find this, this is basically used to represent your sign number. Okay, you see this particular box. This particular box is your most significant bit box. Here it will represent here the value that is going to be either 0 or 1 will be your sign. All right, and the remaining bits are your. So this is what is this? This is a sign representation, and this you have a remaining bits, right? Have remaining 1, 0, 0. What are these? These are called as your magnitude. Magnitude. All right. So this part is called as your magnitude, and this part is called as your sign. Right. So this first bit is called as your sign, and the remaining bits are called as your magnitude. Okay, let me take one more examples to understand this. Say +6, and you have to represent this in a 8-bit format. So how will you represent? So 8-bit, I'll take this 8-bit, I'll take an 8-bit format here. I hope everyone can see. So first one, what will be? What is that? So let's start from here. What is 6? 0, 1, 1, 1. And the rest will be 0, 0, 0, 0, 0. Right? What is here? 0 is your sign, and the rest is your magnitude. What about it is -6? If it is -6, then it will be 1. Right? So in case of unsigned 8-bit numbers, the decimal range is from 0 to 255. All right. So in case of unsigned 8-bit numbers, the decimal range is 0 to 255. All right. Now for a sign magnitude, for a sign magnitude, 8-bit numbers, the largest magnitude is reduced from 255 to 127, because we need to represent both positive and negative numbers. All right. So what is the maximum? The maximum positive number is 0, 1, 2, 3, 4, 5, 6, 7, 8. 8, no? That is 8, right? Just a second. Let me bring this. That is equals to plus 127. All right. This is the maximum numbers, and minimum number is what is the minimum numbers? 1, 2, 3, 4, 5, 6, 128. That is equals to minus 127. Now this is called as the sign magnitude representation. Now there is a one drawbacks of this techniques. What is that? So for addition and subtraction, it is necessary to consider both sign of so what is that? In the case of addition and subtractions, it is necessary to consider signs of both the numbers and their relative magnitudes in order to carry out the required operation. All right, in order to carry out the required operation. Now this is one drawbacks. Okay. Now next is one's complement. I know what is one's complement. You already know what is one's complement, right? What is one's complement? You know this. So what is one complement? So if the question will come like this. So the drawbacks, right? Regarding the drawbacks, let me tell you one thing. So we will move on this one, no problem. So one's complement. How do you find a one's complement? So if the question will come like this, find the one's complement of 1101 with the base. So this is the question, find the one's complement of 01. So what we have to do? So it will be changed into 0011. No, 0010. All right. So this is a very simple one. Next is your second complement. The third technique is called as second complement. Second complement. So in second complement, what we are going to do is that the two's complement number is obtained. How do it obtains by subtracting the corresponding positive numbers from 2n. Right? So it's obtained by subtracting corresponding positive numbers from 2n. So hence the two's complement number is obtained by adding 1 to the first complement numbers, right? So if I give you a question like this, find the two's complements of say 1001 with the base 2, how will you solve? So what we do, 1 0 then 0 1, this is a number, right? So we have to take the first complement 0 1 1 0. Then we have what we have to do, we have to add these two numbers. So how will you do? We have to add 1, right? So we have to add 1. If I say put plus 1, so we will get an answer as right? So we will get answer as 0 1 1 1. Right? This is your two's complement. Here we are adding 1. First we need to convert into one's complement and then add 1 and you will get as your two's complement. All right. Now let me ask you one question. Suppose we have a decimal number, say plus 7. How will you represent in sign magnitude? Sign magnitude using 4 bits. Say if you have to represent using sign magnitude, it will be, what is that? 0 1 1 1. Right? Now in one's complement, how will you represent? One's complement, how will you represent? 0, 1, 1, 1. What about in the second complement? In the second complement, you will get also 0, 1, 1, 1. You can solve and you can verify it, okay? So this is how you, the different techniques of representing your sign, that is for positive and negative numbers. So students, we will stop here, okay, for today's classes. And I hope those who are having trouble with this one, you can drop down your queries in the Google Classroom. All right. So thank you. Thank you for joining tomorrow. Tomorrow you don't have any class. From the next time, I'm going to prepare a slides. Okay. So it will be very easy. So do you want me to? Okay, just a second.
Ma'am, can we leave right now?